Greetings everyone. Today we are going to build a distance measurement device with HCSR04 ultrasonic sensor using ATmega32. The sensor has 4 pins. A high pulse of 10 microseconds in the trigger pin would start the process. And based on the pulse width received on the echo pin after that, the distance between the obstacle and the sensor can be measured. We will use two breadboards. One is for the LCD and another one will be used for the microcontroller and the sensor. I have already connected the VCC and ground wires. Let's add the components. We are going to use ATmega32 for the project. Port B pin 4 will be connected to the trigger pin of the sensor. For the echo pin, we will connect it with the external interrupt 0, which is at port D pin 2. Next, connect the VCC and ground pins of the sensor accordingly. For the LCD, at R0 pin, we will add a potentiometer. Port C pin 4 to 7 will be connected to LCD data pins 4 to 7. The RS, RW and E pins will be connected to port C pin 1, 2 and 3 respectively. There's a small correction in the circuit. I actually have connected the microcontroller in reverse order. The mentioned circuit remains the same. Let's get into coding the chip. I have opened a project in Microchip Studio and included some header files. In the LCD lib.h file, I need to mention the exact port and pins. We will be using two functions in the project. Pulse width variable will store the received pulse width in the echo pin. And rising edge flag indicates if the next flag will be rising or falling on the external interrupt. Distance variable will store the calculated distance. We will start with initializing the LCD. Next, the trigger and echo pins will be initialized for the sensor. We are enabling the global interrupt here. In the while loop, measure distance will return the calculated distance. The distance result will be stored in a string next. We will print the string into the LCD and put a delay of 500 milliseconds. In this function, the data directions for trigger and echo pins are defined. Also, an external interrupt is defined for any logical changes. At this function, it sends a pulse into the trigger pin. Then it waits for the external interrupt to set the pulse width variable. Then distance is calculated with respect to 343 meter per second, which is the speed of sound. For centimeter and millisecond scale calculation, a division with 58 would provide a close result of the distance. Then we have the interrupt service routine. For any logical change in the interrupt 0 pin, this function will be called. We will check if the current signal is a rising edge, and if it does, we will start the timer and count the time until a falling edge is detected. The interrupt is set as both the falling and the rising edges would invoke this ISR. The time value is stored in pulse width variable. Let's build the project, and in the meantime, we will connect the programmer with the microcontroller. I am using a USB ASP programmer to program the chip. I need to connect MISO, MOSI, SCK, reset, VCC and ground pins with the programmer. I will use Extreme Burner to program the chip. Let's select the hex file and hit write, then flash. And the chip is programmed successfully. Let's connect VCC and ground to LCD circuit. It's working. Let's test it with a different setup. If you like this video and would like to watch similar contents in the future, please subscribe to the channel, leave a comment and hit the thumbs up button. Thanks for watching.